Good afternoon, everybody. My name is Lee Ullman, and I'm the Senior Director of the MIT Sloan Latin America Office. The Latin America Office is part of MIT Sloan Global Programs. As part of the mission of the MIT Sloan Latin America Office, our goal is to bring MIT knowledge to Latin America. With the current situation, it's a little bit difficult on travel, so we've switched to this webinar in online version. We are very fortunate to have Professor Robert Pindyck, Bank of Tokyo Mitsubishi Professor in Finance and Economics with us today. As many of you know, Bob Pindyck's most recent research focuses on economic policies related to rare disasters. Professor Pindyck is a real fan of Latin America. In the last 4 years, he's traveled on behalf of MIT Sloan to Chile, Brazil, Peru, Colombia, Ecuador, and Argentina. We're very thankful to have Bob today to speak to us about welfare costs of catastrophes. I'd also like to thank Zach Whitman for helping out with this webinar, and Jacqueline Paris Taylor from MIT Sloan Global Programs. Some rules that you're all aware of. The chat is disabled for everybody, so you're unable to chat with each other. However, we do have questions, and throughout you'll be able to ask Q&As. If you like any of the questions, you'll be able to upvote these questions. And then at the end, we will have a Q&A session with Professor Pindyck. Also, if something is not clear or to many people, things are not clear, please mention it in the question and answer section, because I will be able to ask Professor Pindyck questions if something is not clear to people. So without further ado, I'd like to turn over the mic and the screen to Professor Pindyck. Thank you again for being here, and I'll come back during the question and answer period.
Okay, thank you, Lee. And I can't see all of you, the participants, but you can see me, and some of you may recognize me from some of the talks I gave through the Latin America program, talks in Chile and in Peru, in Bogota, Sao Paulo, Buenos Aires, over the last 2 or 3 years. And if you remember, those of you who heard those talks, if you remember them, they were very depressing because I spoke about the work I was doing on catastrophes. And at that time, the discussions that I gave and the talk that I gave was about all kinds of global catastrophes, all kinds of terrible things that might happen. It was really, you know, an ideal talk for pessimists. And I want to tell you sort of where that all came from. But one of the catastrophes that I talked about in those earlier talks was pandemic. And today I will talk about pandemics and also economic collapse, 2 things we could be upset about and worried about. And this will probably also be a rather depressing talk. But let me kind of go back and tell you a little bit about how all this started. So for the last quite a few years, maybe 7, 8, 9 years, I've been interested in climate change. And I've been interested in the possibility of a terrible climate outcome, a climate catastrophe. What would happen if the climate change situation got really, really bad? Temperatures increased much more than we think they might. And when I thought about that and started writing about that, it occurred to me, well, if we're going to think about a climate catastrophe, which is of course global, shouldn't we also be thinking about other kinds of catastrophes that might occur? And while people I knew in the climate business were worrying about climate change, there were other groups I knew that were worrying about different things. So I knew there was a group at the Kennedy School at Harvard that was worried about nuclear terrorism. And they had done studies indicating that there was a very high probability of a major nuclear terrorist event occurring in the United States or Europe in the next 10 years. And it would be very, very easy for terrorists to bring a nuclear device into the US or Europe and set it off. and that there was a very high probability this would happen. And then there were people that I knew at the CDC, the Centers for Disease Control, at MIT, and other places that were studying viruses. And they said that, look, why are you worried about climate change? Why are you worried about nuclear terrorism? We're all going to be dead anyway from this new virus that's going to happen. I'm exaggerating. And they said that, look, it's very, very likely that there will be new viruses that will be generated. They'll start out in animals and then be transmitted to humans and then mutate so they become transmissible across humans. And it'll be very, very difficult to stop these things. And it'll be worse than the last major pandemic we had, which was the Spanish flu of 1918, 1919. Some of you may know or may have read that the Spanish flu killed close to 4 or 5% of the population of the United States and the populations of Europe. It was devastating. I mean, it's hard to imagine how terrible that epidemic, that pandemic was. But of course, that was 100 years ago. And now we're confronting something that maybe, we don't know yet, may be equally devastating. Maybe it won't be, maybe it'll be more devastating. There's a lot we don't know, which I'll get to. So that was the other kind of catastrophe that might happen. And then some of those people said, well, wait a minute, you know, a pandemic happens on its own, but what about bioterrorism? And lots of possibilities about bioterrorism. And then people said, well, wait a minute, what about, you know, earthquakes? I mean, yeah, we've had earthquakes, but you know, there's a small chance of a really, really devastating earthquake. There's a possibility that one would originate roughly in kind of in the middle of the United States and split the country in half. And what about that? And so on. So I became very interested in this possibility of catastrophes, and I began working with a co-author at the London School of Economics on how you think about this. How can societies, governments think about the multiple potential catastrophes that we face? And the problem we looked at was this, you know, if let's say we face 7 major catastrophes. In fact, I'm going to show you a picture with 7. And let's say those 7 are a climate catastrophe, nuclear terrorism, bioterrorism, a major pandemic, major earthquakes, major floods, and major storms. I'm talking about extremely strong storms. Which ones, if we could avert them, should we avert? Should we avert all 7 of them? Should we partially avert all 7, try to reduce the likelihood or the intensity of all 7? And even if it were feasible to do that, is that the optimal thing to do? And what we showed in a paper that we published in the American Economic Review a few years ago, that the answer is no, that it may well be the case that you would not want to avert all of these catastrophes, even if you did a separate cost-benefit analysis for each one. The cost-benefit analysis would tell you, yes, you should, if you did it one by one. And the reason has to do with the fact that these are big deals. And when you have big deals, then the effects of these things are interactive. And so the benefits and costs of averting one catastrophe are dependent on what you've done with the others. And this is the main idea that we developed and presented in this paper, and that I've talked about in numerous times. Let me show you a figure from that American Economic Review paper. Jacqueline, if you can show, I think it's slide number 2 in the deck, the figure from the AER. That's the one. So let me just get some water. So here's what this shows. It shows, if we look at the left panel, panel A, it shows these 7 catastrophes: virus, that's the pandemic, nuclear, climate, and so on. And on the vertical axis is the willingness to pay in terms of percentage of GDP or consumption that society would be willing to give up to prevent this from happening. So if you look, for example, at nuclear terrorism, and you go over to the left to the axis, it says that society would be willing to give up something on the order of 9% of GDP to prevent it. Now, the horizontal axis is the cost of preventing it in terms of a permanent tax on consumption. So if you go back to the nuclear point and you go down, it says 3%. That says that we could avert a nuclear catastrophe at a cost of about 3% of GDP or consumption every year. That's expensive, all right? Because that dot is above the line, that line is actually a 45-degree line, it means that the benefit in terms of the willingness to pay is a measure of a reservation price, the most that society would be willing to give up to prevent something. That willingness to pay is 9%, the cost is 3%, so that looks like a good deal. That looks like a positive NPV project, okay? Looking at it by itself. The benefits are bigger than the costs. If you look at bioterrorism, it says bio, it's the dot under, that also would take 3% of GDP to avert. The benefit would be 5% of GDP. That too has a positive NPV. In fact, the NPV is positive for all of these things. If you look at climate, instead of a dot, it's a plus sign. It has a cost of about 4% of GDP to prevent, but a benefit close to 5%. All right? So those are the 7 catastrophes. Now, the right-hand panel differs from the left-hand panel in only one respect, and that is on the right-hand panel, we've assumed a greater number for society's degree of risk aversion. We've assumed that that degree of risk aversion is twice as large in the right-hand side as it is on the left-hand side. But still, it's the case that for all 7 catastrophes, if you did a separate cost-benefit analysis, you would decide that we should avert each one. But let's go back to the left side. What that graph says is the dots are catastrophes that, yes, you should avert. The little plus signs are ones that you shouldn't. Forget about them. Leave them alone. So on the left side, it says that we should not try to avert the climate catastrophe or the earthquake catastrophe, but we should avert the other 5. On the right side, it says that with this higher degree of risk aversion, there are 3 of them that we should forget about and not try to avert. Bioterrorism, storms, very bad storms, and earthquakes. But we should avert floods, very bad floods, nuclear terrorism, a climate catastrophe, and a pandemic, the virus, all right? But not bioterrorism. We should leave that one alone. Now, I don't want to go into where these numbers came from. You'll have to read the paper, and you can see where we got all these numbers. There are numbers that came from studies that other people did. How do I know, or why did we say that nuclear terrorism, there'd be a willingness to pay of, whatever it is, 9% in the left-hand slide to prevent it, and it would cost 3% of GDP to prevent it? That came from studies, some of which were done at the Kennedy School, some of which were done elsewhere. And those studies are all summarized in the paper that we published in the American Economic Review. But the point I want to make is a fairly simple one. There are actually 2 points. One is that it is not necessarily ideal for society to try to prevent everything. It's not that we couldn't do it. It might be feasible. It's just not optimal. Because to do it, we'd have to give up so much of GDP, it just wouldn't make sense. The second point is that if you look at this figure, and look at both the left-hand side and the right-hand side, the really, really big catastrophe that stands out is the virus, the pandemic. that one should definitely be prevented. I mean, that's really bad news. And there, the cost-benefit ratio is such that even leaving aside these other things or accounting for these other things, you will always want to prevent the pandemic, all right? So that's where I was at the end of this work. I think we're done with this slide. Let me come back just to me, and I'll talk some more. Now, where have I gone since then? Since then, I've been preoccupied with the following question. All right, pandemics are very important, and so is the economy. The problem is, when we look at pandemics, what they do is, yes, they damage the economy, but they kill people. And we don't really have a framework for thinking about translating deaths into numbers, into economic numbers. How do we think about the value, the economic value of lost lives? And when I bring that up, what a lot of people say is, you can't, you shouldn't, that's horrible. Go back to your ivory tower and stop. We don't want to hear anymore, because lives are precious and we can't value them, all right? And I understand that. I understand that viewpoint, but there are two problems with it. One is that I'm an economist, so I put everything in economic terms. That's my business. But secondly, and more seriously, if we don't, it makes it very, very hard to come up with economic policies. I'll give you an example of this. Let's suppose that we could reduce, and I'll talk about the United States because I have the data for that. Suppose we could reduce the speed limit on all roads to 30 miles per hour. All right, that's about 45 or so kilometers per hour. Suppose we could do that. I mean, we could actually. Suppose we did do it. We would reduce the annual fatality rate on car accidents in the United States from about 35,000 per year to about 5,000 per year. There would still be accidents, there would still be some fatalities, but most fatal accidents happen at speeds well above 30 miles per hour, or 45 or so kilometers per hour, well above that. And you might say, well, how would you enforce it? I mean, you need so many police out there checking. It's actually very easy to enforce, because you'd have a requirement that all cars, before they're sold, would have a cutoff that would cut off the acceleration once you hit 30 miles per hour. Couldn't go any faster. It would be built into every car. So we wouldn't even need state troopers, police, roaming the streets to make sure people didn't speed, because nobody could speed. So it would be very easy to enforce. So why don't we do that? Lives are precious. We could save 30,000 lives. And the reason we don't do that is because the cost of that is enormous. It just would have an enormous cost on people's behavior, on how they go to work, what they do, how they can travel. It would be very, very high cost, and that's why we don't do it. So economists and policy makers have been looking at the value of life for a long time now, and they've developed something called the value of a statistical life. And what it means is that if you take a person, just an anonymous statistical person, and ask, what is the value of that person's life? Well, one way you might measure it is by the kinds of decisions that people make. And people make decisions in terms of the jobs they take. Some people are willing to take a risky job if it pays more. Some people are not. And it affects the kinds of decisions they make in terms of travel and so on. So one thing that economists have done is looked at these decisions, and from that deduced how people value their own lives in terms of the decisions they've made. And from that, in the United States, they've come up with a number. And that number, which is used by the Environmental Protection Agency in setting regulatory guidelines, used by the Department of Transportation in setting regulatory policy, for example, requiring airbags in all cars, which is costly. Used by government agencies, that number is around $10 million per life, all right? And the UK, Britain has done the same thing. They've come up with a different number. It's about $4 billion per life. Different countries have done this and come up with different numbers. But we now use these VSL, value of statistical life numbers. And so my co-author, Ian Martin at LSE, and I went back and we said, look, can we use this and integrate this into a model in which we look at only two kinds of catastrophes? We're going to simplify things. We're going to forget about climate. We're going to forget about nuclear terrorism, forget about earthquakes. We're only going to look at two things: pandemics and major economic contractions, really bad economic recessions. Things on the order of the Great Depression of the early 30s, the financial collapse of 2008, 2009, and the deep recession that set off, things of that sort. And what we want to do is understand first, what do we think is society's willingness to pay to prevent either of these things and to prevent both of them? That's the first question. The second question is, how do they relate to each other? How do they interact? And what we can show is that the presence of economic uncertainty raises the willingness to pay to prevent a pandemic. And likewise, the possibility of a pandemic raises the willingness to pay to reduce or eliminate economic recessions, bad economic outcomes. And the reason for that, if you think about it, is actually fairly simple. Think about what the possibility of an economic collapse does to society's willingness to pay to prevent a pandemic. Well, a pandemic is awful. A pandemic will reduce our consumption, reduce everything, kill people. It'll be terrible. If on top of that, we face the possibility of an economic collapse, not caused by the pandemic, but separate from the pandemic, then we really want to prevent the pandemic. Then things are really bad. In other words, if you're already facing lots of bad things, one more really bad thing is terrible. It's worse than it would be if you weren't facing all of those other bad things. So this is what's going on. When we look at pandemics and the possibility of an economic collapse or economic fluctuations, economic uncertainty, this is what we find. And what we did is we used the VSL value of a statistical life numbers. We did it for the United States. And we use those numbers. And then we use numbers on pandemics. And of course, we did this before the current pandemic. You know, now we have more data, or we're going to have a lot more data in a few months. But we wrote this paper about a year or so ago. 2 years ago was the first draft, and we revised it. We wrote this paper a while ago before the current pandemic began, using data from the Spanish flu and other pandemics, other epidemics, SARS, bird flu, and so on, other things that happened. And that's how we calibrated the model for pandemics. And then in terms of economic fluctuations, economic recessions, and so on, well, there we have lots of data. You know, we can go back about 100, 130, 140 years and look at what's happened across countries, and we have plenty of data. And so we can use that data to calibrate the willingness to pay for an economic collapse. In fact, we used numbers, historical episodes of economic downturns from Robert Barrow at Harvard and one of his co-authors, a study they did. By the way, this study of pandemics and economic collapse is in a paper that I think Lee is making available, or will make available if he hasn't already. It's somewhat technical, but if you look at read the introduction and the last couple of sections, it should be fairly readable. So we did this, and what did we find? Well, let me put up another figure. This is Jacqueline, I think it's slide 4 in the deck. If we can look at that, I'll show you what we found. So this is figure 2 in this second paper, this paper that we wrote. It hasn't been published yet. And let me explain what's going on. Here, we're looking at simply the willingness to pay for society to prevent something, all right? And we're not looking at the cost of preventing something. We're simply looking at society's, what should be society's willingness to pay as a fraction of GDP every year, which you'd be giving up every year. So let me turn to a couple of lines. One line on the left-hand side, we're going to look at the left-hand side. One line on the left-hand side is labeled WC, and the C stands for consumption, for a consumption disaster. In other words, an economic, serious economic downturn that would reduce GDP and reduce everybody's consumption. And again, fitting this to data over the last 120 years for about 100 countries, this is the willingness to pay. And as you can see, it's really high. It says that depending on the degree of risk aversion, and let's take the middle value of 3. Later on, I can tell you more about this coefficient of risk aversion and what it means. But if you take that middle value, which is pretty much what economists and financial economists believe is the case in the United States and most of the developed world, if you take that number 3 and you go up and you look, what is the willingness to pay on that pink line, W sub C, it's about 25%. That's a huge number. We'd be willing to give up 25% of GDP to prevent an economic, big economic downturn. Now, what if there was no pandemic? What if we didn't have to worry about pandemics? Then the willingness to pay would be the dotted line just under that, the one that's labeled WC prime. And then the willingness to pay would be lower. Instead of 25%, it might be about 22% or 21% of GDP. So the fact that there's a possibility of a pandemic raises society's willingness to pay to prevent a major economic downturn, all right? Now let's go down to the blue lines. If you look at the dashed line labeled W sub D, D stands for death. That's a death event, in this case, a pandemic. What's the willingness to pay to prevent that? Well, with a coefficient of risk aversion of 3, it's about 10%, 0.1. You see that on the graph. That says that we should be willing to give up roughly 10% of GDP to prevent an event such as a really bad pandemic, the kind of event we're experiencing now. That's what we should be willing to give up. Now, what if there was no problem of an economic downturn? What if we didn't have to worry about economic uncertainty? What if we could somehow wave a magic wand and get rid of recessions, major economic downturns? So that's no longer a problem. Then what would happen? Then the willingness to pay to prevent a pandemic would be given by the dotted line below that, the one labeled WD prime. It would be lower. In fact, the willingness to pay to prevent a pandemic would be not 10%, but maybe 6%. So what we get from this is that the possibility of an economic downturn magnifies the willingness to pay to prevent a pandemic, and the presence of a pandemic raises the willingness to pay to prevent an economic downturn. The black line at the top, labeled W sub C comma D, that's the willingness to pay to prevent both. What would we be willing to give up to prevent both an economic downturn and a major pandemic? And the answer is around 30%. It's not the sum of the willingness to pay for each one, It's less than that, but it's 30%, right? So that's what's going on. Now, those numbers might seem to you to be very, very high. I mean, 10% of GDP to prevent a pandemic, that's huge. The United States, for the past several decades, has spent almost nothing to prevent a major pandemic. We spend almost nothing. The budget of the CDC, for example, the annual budget is about $8 billion. That's like a rounding error in terms of government spending in the United States. It's very small, nothing. But should we be willing to spend this much? You might say, well, wait a minute. You know, this must be because you're using a big number for the value of a statistical life. You're using this $10 million number. So on the right side, the panel on the right side, we're going to vary the VSL. Now on the left side, this VSL number translates into a number for, it's called S. Don't worry about that, but S of 7 corresponds to a VSL of about $10 million per person, per life saved. On the right side, we're going to vary this. So for example, if you went down to the left all the way to 2, S equals 2, that corresponds to a VSL of not $10 million, but maybe something like 2 or 3 million, much, much lower. All right, what if we do that? What happens then? Well, what we get, as we'd expect, is a much lower value for the willingness to pay to prevent a pandemic. Now, instead of 10% of GDP, it's maybe something like 3% of GDP, all right? It's again influenced considerably by the possibility of an economic downturn, but it's a much lower number. That willingness to pay to prevent a pandemic or related type of death event is much lower, maybe 3% of GDP. But think about that, 3% of GDP. The United States GDP is about $25 or so trillion. Take 3% of that. We're talking about something close to almost $1 trillion, $700 billion. We're talking about almost the entire discretionary budget of the US government, a very, very big number. So what this tells us is that even with a much lower number for the value of a statistical life, even if we make that number much lower than what we get from people's behavior, what people seem to indicate that they value lives at, even if we use a much smaller number, we are getting a willingness to pay far, far higher than anything we even dream about in terms of taking actions to avert a pandemic, avert what we are now experiencing. And indeed, that's why the current pandemic is so bad, because we've done nothing. We've done virtually nothing in the United States. I don't know what's been happening in Argentina, in Chile, in Brazil, and so on. I can tell you that in the United States, we've done almost nothing to prevent a pandemic or to even create a response to a pandemic. We don't have stockpiles of the things we need, ventilators, face masks, whatever, gowns, and so on. We don't have the capability to quickly develop a vaccine. We don't have the capability to quickly test many, many drugs to find things that might be useful to reduce the effects of the virus. We've done almost nothing in the United States. And in fact, this says that we should have been doing a lot, a great deal, but we haven't. And this kind of brings me back to the original study. When I did the original study with my co-author, the one I talked about before, where we looked at several different kinds of catastrophes, nuclear terrorism, and so on, you know, I'd read a book by Richard Posner, a justice a judge who's written extensively in economics, and he's written a book. He wrote a book about a decade or so ago called Catastrophe. And the major point of the book was, hey, look, a lot of bad things can happen, and we're not doing anything. And it's true. That's what kind of stuck in my mind, that we really are not doing much. Take nuclear terrorism. Why would it be so easy for terrorists to bring a nuclear device that would have the power of the Hiroshima bomb, so easy to bring that into the United States undetected? Why is that so easy? Well, it's easy because A, the engineering and physics are trivial. All you need is enriched uranium. If you have enriched uranium, any freshman physics student knows how to build a bomb. It's very easy to do that. All you need is the enriched uranium, and that's possibly available. And then it's very easy to bring it into the United States because we don't check anything. We don't check all these containers that come in, these huge containers that come in into the coast of the United States. So it's very easy. We spend almost nothing on avoiding a nuclear terrorist event. And you can go all through, these different things that we talked about in our paper. We spend very little to prevent these things. We don't worry about them. We don't worry about them until they happen. So coming back to pandemics, we haven't worried about pandemics in the past. The only people that worried about them were people that were epidemiologists, virologists, some of them at MIT, some of them at the Centers for Disease Control in Atlanta. They worried about these things. People at the World Health Organization worried about these things. But people in government and people who controlled the money didn't worry in the least about this stuff. It wasn't something on their radar. It was low probability. I mean, after all, it's been 100 years since the last major pandemic, the Spanish flu. So why worry about these things that probably wouldn't happen for years? And, we have other things to worry about. Why worry about these long run problems? And so we didn't do much. And what this study says is that we should have. So let me stop here. I think I think I've depressed you enough. And let's see if we can have a discussion and get some questions. So I think we don't need the figures anymore. We can get rid of the graph, unless somebody wants to refer to them.
Bob, so the first question was, can you clarify the difference between bioterrorism and viruses? And could the latter be a manifestation of the first? Right.
So we did, in our original paper that was published in the American Economic Review, we made a distinction between bioterrorism and we called it a megavirus, horrible virus pandemic, on the grounds that the bioterrorism is where terrorists take an agent, it could be bacteria, it could be a virus, that they somehow get a hold of and they spread it, all right? And they spread it around a country. They spread it around the United States or Europe or whatever, Latin America, whatever. And that would have a devastating effect. I mean, just imagine if you're afraid to go anywhere because you're afraid, you get on the subway, you get on the bus, you get on a train, you go into a store, and somebody, could have spread some kind of horrible bacteria around and you might catch it, or virus. So we treated that separately, and also it's been studied separately. But in the original American Economic Review paper, we showed how you could take account of the fact that they're actually related. And the fact that when actually not just bioterrorism and a pandemic, but bioterrorism and nuclear terrorism are related. Because if you're going to try to avert one, it would help you to avert the other one. A lot of what goes into averting these terrorist events is intelligence. Lots and lots of money spent on intelligence. So you can deal with them together. But we treated bioterrorism and pandemic separately because they are kind of different in the way they would work.
Bob, the next question, can you please clarify the meaning of N and S from the graph? I don't know, Jacqueline, if you can bring up the slide again.
Oh, this is the first one, the graph on with the 7 different, you mean that one?
So if Juan Pablo Troncoso, if you can verify it's the N and S from this graph.
Or is it the second one I showed? Oh, it must be this one. Yeah, I think it's this one. Okay.
Exactly. It's this
All
one.
right. So I see what you're saying. So the horizontal axis on the left panel, it's actually not an N, it's a Greek letter eta. Sorry about that. It's a Greek letter eta. And the other one is indeed an S. S is easy. S is related to the value of a statistical life. If the VSL, the value of a statistical life, is $10 million, that's the number that's used by regulatory agencies in the United States, by the US government, then S would be 7. And if you think the value of a life is greater than 10 million, S would be a higher number. If you think it's less than 10 million, it would be a lower number. If you went all the way to the end, to the left, where S would be, let's say, 1, that would correspond to the value of a statistical life of something between $1 and $2 million. So that's what S means. Eta, the other number, is a coefficient of risk aversion. So to put it in basic terms, your coefficient of risk aversion, let me assume that you have some of your wealth invested in the stock market and some of it invested in bonds or other relatively safe assets. I don't know what the breakdown is, 50-50, whatever. But if it's something on that order, then your index of risk aversion is around 3. Maybe it's 2, maybe it's 4. It tells you how much you don't like risky situations. And it enters into this because these are all potential catastrophes as opposed to, it's going to definitely happen next year. And the more risk averse you are, the greater your willingness to pay to prevent something that you don't know if it's going to happen, but it could happen. Did that clarify it?
So Bob, we're getting a lot of questions. I'm combining 2 of them for you. The question of somewhat combined is, if society is willing to pay such a high economic cost to avoid a pandemic, what do you think they're willing to pay? Do you think they would be even willing to pay a higher cost to end the pandemic? And a follow-up on that is, what are the practical advices that you can give leaders in order to modify this short or long-term policy for the next weeks, years to come?
Okay, so there's sort of like 2 embedded questions. What I did in this academic work and these papers is look at the question of a potential catastrophe. What are you willing to give up to prevent a potential catastrophe? Well, we already have the catastrophe. I mean, we're now living. We're doing this as a Zoom meeting. I'm not sitting in Buenos Aires or Sao Paulo because of the virus. So we're now dealing with it. And we'd be willing to pay a lot more if it's for certain. I mean, it's very different to say that there's a 5% chance of a pandemic in the next year or 2, as opposed to it's here. It's here right now. So we'd be willing to give up a lot to get rid of this thing, to stop it, to at least limit it, to prevent it from becoming too bad. How much should we be willing to give up? Well, I haven't done the calculation. I've seen other numbers, but the numbers come out to, again, it depends on how you value human lives, because the major effect of this thing is that a lot of people are going to die. We don't know how many, but it's going to be a big number. And so it depends. In the United States, for example, is it going to be 500,000 people? Is it going to be 1 million, 4 million? We don't know. But if you look at possibilities, and depending on what you use as the value of a life, we ought to be willing to give up a great deal to limit this thing and make it go away eventually without causing too much damage. And that's really what we're doing. I mean, the policies in place everywhere, except actually in Brazil, and that's sort of interesting. It looks like Brazil is not doing very much right now, but elsewhere, the policies in place elsewhere are very, very costly in terms of the economies. I mean, look, we are going into a major recession of 1930s depression magnitude. We are probably going to see an unemployment rate in the United States and in many other countries well above 10%, probably 20% or more. The peak unemployment rate in the United States during the Great Depression was 25%. We're going to see something close to that. We're going to see a drop in GDP of around 20% this year, in all likelihood. So we're going to be paying a great deal to limit this, but I think it's what we should be paying because there are a lot of lives at stake here. So I don't know if I've answered the question. Tell me if you want me to follow up, but let me stop.
So one of the questions is, and I'll just shorten it, is the low probability of a pandemic, people weren't really willing to do anything, but the perceived probability of a nuclear war, the Cold War and all the investment, it was so great to prevent a nuclear war. So why such a large amount to prevent nuclear war, whereas here, such little investment to prevent pandemic?
I think the answer for nuclear war, we did spend a lot, and we quite rightly, but we knew that in some sense it was a strange kind of expenditure. You know, nuclear war during the Cold War was mutually assured destruction. And we lived under the assumption that we and the Soviet Union at the time were rational actors, that neither we nor the Soviet Union wanted to see an outcome where, you know, everybody's obliterated, where both countries are totally obliterated, which is what would have happened if we engaged in a nuclear war. And so we had that as a way of kind of putting somewhat of a lid on things, but we spent a lot of money. You know, nuclear terrorism, the problem with that is we're dealing with irrational actors. We don't know whether terrorists who are willing to go the nuclear route are thinking this way in terms of, well, rationally what's going to happen and, you know, what's the rational thing to do. That's why it's so unsettling. And a pandemic is unsettling because we could lose a lot of lives, a great amount. The problem is that with nuclear war, we were educated to understand, at least I'm older than maybe some of the participants, but I was educated to understand that nuclear war would be absolutely devastating, that almost everybody would die. There'd be nobody left at the end of a nuclear war. That's not quite the case with a pandemic. It's bad, but it's not like nuclear war. And I think that's why we haven't spent much money on preventing pandemics.
So Bob, a couple of questions they're asking about the graphs. First, when you mentioned the WTP, is it for the United States? How is it calculated? And then the other question is the model based on one or more year, where if we spend money to reduce risk in year one, there could be a difference in probability of catastrophes in year two?
Right. So the second question is easiest to answer because it's every year. In other words, the model is built so that you're always facing these threats. And, you know, it can happen multiple times. You could have, I mean, as an example, you could have a nuclear terrorist event. It could happen. And then 10 years later happen again. You can have a pandemic, as we are now. It goes away eventually. And then 10 years later, 15 years later, 5 years later, a different pandemic happens. So it assumes that we're always facing this risk, this possibility for each of these catastrophes, in the case of a pandemic and so on. Likewise, with an economic downturn, we could have a terrible depression and it can happen again, you know, multiple times. So that's the second question. The first question is the data and where did we get the numbers? So I used data for the United States. So for the pandemic, for example, I used US data. That's where the $10 million value of a life comes from. But as I mentioned, I could have done this for other countries. As I think I said, the UK, their government, the UK government, when it does regulatory analyses, they use a lower number for the value of a life. They use it's about $4 million per life. And they use that for the National Health Service when they decide how much money should be spent on the National Health Service. So the numbers I'm using are for the US, and again, it's a steady state. When we say the willingness to pay is, I don't know, 5% of GDP, it means We are always giving up 5% of GDP every year to prevent this potential catastrophe from actually taking place.
So Bob, thinking more of your other role as applied economist, there's a question, should we start closing our bank accounts, selling bonds? How can we prepare for the following potential economic depression? What's next?
You know, so I first of all, I don't, you know, at MIT, anywhere, I don't like to give advice about what to do about the stock market and bonds. So I'm not going to advise people on what to do with their wealth, whether to invest in stocks or bonds. You know, the market today, it actually, at least in the US, the market went up quite a bit. Not clear why. But, you know, the market is a lot lower than it was before the pandemic started. Before the pandemic started, the market was, stocks were priced pretty high. But you know, I look at investing in markets as a long run thing, not trying to time the market. So I guess what I would say is, you know, do what you normally do, have a diversified portfolio. Don't think that you're going to be able to time the market, because you can't. You don't know when the next, you know, big downturn or big upturn will happen. And, you know, take on as much risk as you're willing to live with. If you're extremely risk averse, if you don't like risk, you shouldn't have, even if there was no pandemic, forget about the pandemic. If you're very risk averse, you should not be heavily invested in stocks. You should be more invested in bonds and you know, safe assets, treasury bills, government bonds, things like that, because they're safer. So it depends on your own willingness to endure, take risk.
So Bob, going back to WTP, people are fast to express when they are not paying, but the government is different when they are directly burdened by the payment with lower wages, unemployment, low interest rates on savings, etc. How is the WTP calculated?
Well, the WTP is a willingness to pay for society. It's what we call a reservation price. Let me explain what that means. You know, when I get up in the morning, I have to have a cup of coffee. And I mean, I will pay $20 for that first cup of coffee. That's my reservation price. The second cup, I don't care about. But that first cup, I'm willing to pay a lot. Now, I don't have to pay $20 because I can go out and get a cup of coffee for $2 or $3 or, you know, whatever. And today, I can't go anywhere and get it because everything's shut down. But normally, that's what would happen. But $20 is what we call a reservation price. It's the absolute maximum I'm willing to pay. And every one of you that's on this webinar has a reservation price for everything, for that first cup of coffee in the morning, if you're a coffee drinker, you know, for something you're going to eat for dinner, for going to see a show, whatever it is, you have a reservation price. And you hope that you don't have to pay that much. That's the most you pay, but usually we don't have to pay that much. Well, it's the same thing for society. The willingness to pay that I calculate is what we calculate to be the most that society should be willing to give up, sacrifice, to achieve some result. And when we say 5% of GDP or 10% of GDP, it doesn't mean that that's what it would take to achieve that result. We might be able to do it with much less than that. That's fine. This is the most we'd be willing to give up. Maybe we could avert, prevent nuclear terrorism, the next pandemic, with less than 5% of GDP, maybe only 1% of GDP. I don't know. But this is the most we'd be willing to give up. That's the meaning of the WTP. Think about it in terms of your willingness to pay for that first cup of coffee.
So Bob, the final question, there are many questions, but unfortunately we've almost just about run out of time, is looking forward more. What is your opinion on the measures the US government is taking to avoid a deep recession?
It's not enough. It's too little, and it's also too late. It's happening too slowly. So, I mean, I'll just give you, everybody's going to be incredibly depressed after this. I feel bad about that, but that's how it is. Look, the US, you know, we passed a bill, a $2 trillion so-called bailout bill, a response bill. First of all, you know, to get unemployment insurance, if you're now thrown out of a job in the United States and you try to apply for unemployment insurance, the line is busy. You won't be able to. You're going to find out that the website is crashing. You have to call the phone. Nobody answers the phone. There are huge delays in trying to get unemployment insurance, and it doesn't cover everybody. You know, if you're a gig worker, if you're an Uber driver, if you have a, I don't know, a food stand or something, you know, if you're working part-time, you're not going to get unemployment insurance. And you know, it's supposed to provide loans, low interest loans that might even not have to be paid back. It's all ambiguous for small businesses ranging from restaurants to, you know, exercise studios, anything like that. Well, how does that work? Nobody's able to get a loan right now. So it's very, very hard to roll this thing out. It's going to take a long time to roll this out and actually get money to people. And B, it's not enough money. It's going to end up with still, you know, we're going to be in terrible shape 3 months from now. And we're going to need another very big bailout bill or assistance bill 3 months from now. The Fed, the Federal Reserve, is doing a lot. It's doing as much as it can to provide liquidity. So at least we're not going to have a repeat of what happened during the financial collapse of 2008, which was a freeze up of credit. I mean, you know, commercial paper, the commercial paper market froze completely in 2008. You could, AAA companies could not issue commercial paper. So that won't happen because the Federal Reserve will make sure that that won't happen. But in terms of unemployment, in terms of people not being able to get income, not being able to buy food, not being able to pay rent, not being able to buy basic things, not being able to get medical care, it's going to be terrible. So the government is not, I don't think, is doing enough. And the whole response in the United States to this pandemic is it's not coordinated at the federal level. It's states doing the best they can, different states doing different things. It's too bad. So we're in a pretty bad period right now. I wish I could cheer you up, but I don't know. I can't think of what to say to cheer you up.
So Bob, someone wrote to me that just like you mentioned with the United States and Brazil, it's the same thing, that the federal government is not actually stepping in, but states and mayors and governors are trying to do something coordinated to help. And on that note, on behalf of the MIT Sloan Latin America office and MIT Global Programs, we'd like to thank Bob Pindyck for doing this talk for us. We'd like to thank all of the participants across Latin America and the world who spoke today, asked some questions, and joined us. And we'd also like to let you know that our next webinar will be on Tuesday, April 28th. We will send out an email. It will be with Professor Roberto Rigoban about healthcare and macroeconomics and how Latin America can learn from this relation between the two. So thank you very much to all of you. Please stay healthy and well. Thank you very much and have a good evening. Thank you, Jacqueline. Thank you, Zach. And again, thank you, Bob. Please be well and safe and healthy. Good night, everyone.
Thanks, everyone. And I hope I'll get to see some of you participants in Latin America next time, rather than via Zoom.
Yeah, we hope to have you down here when everything calms down. Thank you again. Good night, everybody.